I'm going to stand really close to the screen because I pretty much couldn't read it. But yeah, hi everybody. I'm Philip Lee, just in case anybody's wondering. But I work on the Tinkercad team at Autodesk, and thanks to Google and the Blockly team for having me back to give an update on what we've been working on this year on Tinkercad and the Codeblocks environment. Codeblocks is our block-based programming environment for 3D design, and today I'm excited to share how we made the experience more tinkerable by allowing you to run individual or stacks of blocks just by clicking them. So here's the quick agenda. First, for those who aren't familiar with Tinkercad, we'll briefly go over that, and then we'll go over the progress that we made in Codeblocks and our click-to-run feature. So first, what's Tinkercad? Well, Autodesk Tinkercad is a free web app for 3D and electronics design, coding, and simulation. We've been getting over 5 million monthly active users at this point, and millions of teachers also trust our application to use in their classrooms around the world. But how do you make something in Tinkercad? Well, we have our 3D workspace, where you can drag and drop shapes onto the workspace work plane from our shape library. You can adjust them by moving, scaling, rotating. You can also combine them together by grouping them. And then you end up with something like this. Pretty straightforward, right? Very kid-friendly, accessible. We also have our circuits editor, where you can program Arduinos and microbits without the actual hardware, and by using blocks or text code, pretty much. One last plug for now. We have our special SimLab environment in our 3D workspace where you can run physics simulations, and my fellow developer, Joshua, shout out to Josh, has made many improvements this year. We've added a variety of motors, key bindings so you can drive those motors with your keyboard, and motion tracers so you can visualize and measure the kinematics in the scene. At Tinkercad, we try our best to give students a way to play with complicated concepts in simple and accessible ways, which brings us to Codeblocks. So what is Codeblocks, right? It's this. This is a sneak peek, by the way. We don't have this UI layout that I've been working on in production yet, but I have screenshots for it, so that's yay. Here's what a new typical workspace looks like in Codeblocks. We use operations similar to the 3D workspace, where we create shapes, transform them, and combine them using the blocks provided. This is an imperative programming style that we went with in Codeblocks that matches the step-by-step workflow that creators in the 3D workspace do. So when you place a shape, the next command should be the one that operates on it. And also, when you press play, it runs all the blocks from top to bottom, playing out the design in the 3D viewer. And here's an example where we take some blocks, some boxes, and arrange them accordingly so that it subtracts portions from the bottom, and then you make a really simple IKEA table, not sponsored. You can imagine the stack of blocks can get very tall as you assemble all the commands in your design, which can get difficult to read and organize. So we've added templates that pretty much work like functions to help with breaking up code and work with smaller stacks. This has helped us move a step closer towards helping people experiment and tinker with their projects. Sorry if I use tinker too much, by the way. It's what we do. Still, running the whole design all at once has its challenges. We found that it can be difficult for new users to understand what each block even did in our toolbox, unless you assemble a few together just to start. And it's also hard to test small sections of code when you have this huge stack in a big project. We've had users just use conditionals to separate certain sections just to test those smaller chunks. And another technical limitation that we've had with templates specifically is that definitions, we have these define blocks and then using the template blocks, and they had to be positioned above everything else to be defined correctly. So that was a little thing on our own code generation, and that was a challenge. With those challenges in mind, we drew inspiration from scratch, as many of us do, obviously, to address these issues. We found that allowing you to click each block in the workspace and the toolbox to get something to happen was very playful and very intuitive. So how do we bring that ease of use to Codeblocks? And what would you need to change to manage, what would we need to change in our code evaluation to allow this capability? So that's what we did. We added clicks, pretty much. Um, woo, clicking. Clicking on a block stack to execute them, pretty much. And here's an example where you click you get instant feedback when you click on the blocks, stacks of blocks, or even blocks in the toolbox to manipulate the scene. Now that you've seen what we've accomplished, let's dive deeper into how we did that. So this is kind of the code portion of it. So to get click to run to work in Codeblocks, we've had to do some refactoring. Just to give you an idea of what gets generated, and like the user doesn't see any of this. This is just what we feed into our 3D engine. When you execute the code, this is some of the pseudocode that we have on the right. We build this long promise chain to make sure like each action is done in order. And if separate stacks are in the workspace, then based on their position, they get added to this promise chain accordingly. Before our refactor as well, the variables and templates that were defined, they get defined locally. So they get stuck in that promise chain, and they're not very accessible in subsequent runs. Whenever you run the code, it restarts from fresh. I don't want to use Scratch, but it starts from scratch. And if we had used this in click to run, our variable values would be lost, and same with our templates. They wouldn't be defined properly. And so we put in the effort to extract these variables and templates out into a persistent context object that gets passed into each evaluation scope. We now store a variable map, a way to keep track of our currently selected object in the 3D scene, and the latest template definitions in this context. So in terms of application, when creating shapes, we store that reference of that shape, and when we want to manipulate it, we just use like a get function that we wrote to grab that ID. Same goes for variables. We have get and set functions that interact with our variable map when we see a variable block being used. And when generating code, we also filter out all the defined template blocks first, save that in our template definition object, and then access them later when we actually generate the rest of the code and put those template definitions on top of our promise chain that I mentioned earlier. So that's kind of how like our 3D engine is interpreting all these things to make sure things are defined and usable. As a result of some of this refactoring, we unlocked some new features that we didn't have before, like variable tracking, where as you're playing through the design, you can see what the variable values are, which is very helpful in debugging, especially in a coding environment. And then to address that third challenge that I had earlier, where those template definitions had to be placed in a certain, very specific place, now that's not an issue, because now they can be placed anywhere, because we filter those out to begin with. Now that we have those foundational pieces, we move forward to implementing our click-to-run feature. And the key to this was this event that we saw in the Scratchblocks code called stack click. And we made changes in our code generation to support just getting fed a root block and only generating the code from there. And then we attach any template definitions on top. In this example, I'm just clicking this green roof block, and it only generates that code instead of generating all these other things. And then in this next example, I just click this move block over here, and then it only applies the move operation on that saved shape that we have. Click to run works on most of the blocks that we have in the toolbox, but empty loops and comments, they don't really do anything, so we just kind of ignore them. We don't generate anything when you click them. We added some special behavior to our defined template blocks as well, because usually when you click run, they don't really do anything. They're just there to define the function. But I imagine like when you click on a template, you want to kind of see what it makes. So we allowed it so that it has a special behavior. When you click it, you kind of see like what that portion of the code does. Another neat feature that we're able to add by leveraging the tech that we have in our 3D workspace was shape selection. So you can kind of go back and forth, selecting shapes in the 3D viewer, and then going back to clicking blocks in the workspace and apply operations to those shapes for more experimentation. Unfortunately, there's no way to reproduce that like selection logic. Like when you're clicking on a shape over here, it's not like it's going to reproduce a block on the other side just yet, but we hope to address this in the future. And one last thing we were able to do, which is kind of relevant, but we were able to utilize the read-only flag in Scratchblocks, Blockly, to provide a viewer mode, which has been a game changer in our gallery. It used to be this wall of like static thumbnails, but now we're able to explore what our community is making, what kind of cool shapes they're doing, and what kind of code they're writing, without having to jump all the way into a whole editor experience, which can be like very resource intensive. So yeah, that's pretty much what we were able to accomplish this year. Just to recap real quick, in order to implement click to run, we had to change how we were generating code almost entirely and provide a reusable context to any code we generate to pull information that we need. And click to run allows our users to try smaller, more manageable portions of their project and explore more options quicker. Here's some cool designs from our community from this past year. Shout out to our own Joshua again. He made this cool block with our math blocks, our cool 3D design, a truncated icosahedron. I've had to practice that word a few times. And the last example here, it's kind of fuzzy, but it's a great example of taking our Codeblocks designs and moving them over to our 3D workspace where we have this simulation environment. We applied a motor to this fancy procedural model, and we spin it faster and faster until you get this fancy zoetrope. So yeah, that was fun to add as well. What's next? We're interested in more ways that we can integrate Codeblocks with our 3D workspace, have these two environments work more closely together. We want to improve tutorials and our documentation for our students, and of course, being able to have teachers grade these things too a little more easily. I know that's a hard problem to solve, but we're hoping to address that soon. We want to add more blocks. So if any of you have any suggestions, feel free to reach out to us. That'd be great to add. And just like last year, haven't had the time yet, but moving off the Scratchblocks fork. I know you guys are pushing for that, and I definitely want to do that too. There's so many accessibility features that are there already, so hoping to get on that too. But yeah, that's pretty much it. Thanks for listening. I don't know how much time I have, but any questions?
Yeah, so the new template looks awesome. So good job. That looks great.
Thank you.
Quick question. I saw that you were able to call a template from a template. Can a template recursively call itself?
I think so. Yeah. Because it'd be just like, yeah, yes.
Okay.
Yes.
Right.
If not, let me know.
Okay, we'll test it out.
That's a bug. Cool. All right, then. It is a lightning talk. I guess we're moving on.